Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O Levels Physics 5054. In this video, we are going to present you the solution of the October-November 2024 1-2 paper. The paper I am using has been created by the Cambridge Assessment and International Education. In this video, I'm using these papers. I have downloaded them from their website. In this video, I am only going to present you the solution. So the papers and the marking scheme, they both are the property of the Cambridge Assessment International Education. So let's start this paper. The time allowed for this paper is 1 hour. And this paper is multiple choice questions. It has 40 questions and we have to answer them. So the question number 1 is coming up on your screen. And here we go. The question number 1 is on your screen. The diagram shows cloths peg. And the cloths peg, here you can see we have a certain height. And in here, which device is suitable for obtaining an accurate value for the height of the cloths peg? Okay, a tape, a meter rule, a micrometer, a measuring cylinder. So I want to measure this height. So which one is the best? A tape, a meter rule, a micrometer. I think the best thing can be a micrometer. That will give you a very accurate reading. So let's check. What's the answer? C is the answer, sir, which is the right answer. Then we have which set of quantities are all vectors? So A option is acceleration, which is a vector quantity. Displacement is a vector quantity. Velocity is a vector quantity. So it looks A is the right answer. So let's check. A is the right answer, sir. Question number 3. The graph shows the motion of a cyclist during a ride that lasts for 14 seconds. What is the average speed of the cyclist for the ride? You know, the average speed is the total distance traveled by the total time. So how much is this total distance? So let's check how much is the total distance. So the average speed is the total distance traveled divided by the total time taken. So let me show you. I have done this on a paper. And okay. So here we go. Average speed is the total distance traveled divided by the total time taken. So the total distance traveled here is 28 meters and the total time taken is 14 seconds. So the average speed will be 2 meters per second. So let's check 2 meters per second. Do we have this answer here? Yes, sir, we have this answer here. And this answer is, I think, A. A is the choice. So let's check if the answer is A. The answer, let's check. Question number 3, A is the right answer. So let's go to the next part. Here we have question number 4. And the question number 4 is, the diagram shows how the velocity of a train varies with the time. Which section of the graph shows where the magnitude of the velocity of the train is decreasing? Okay. So here the velocity is in positive section. Here the velocity is in the negative section. Here you can see as the time is passing by, the graph is coming down, which means that the velocity is decreasing. Here the velocity becomes 0. And here again, the velocity starts as a negative. Negative means its direction has changed. The train is now moving in the opposite direction as the direction of the train was in the first section. So now the train is moving in the opposite direction. That's why it's in negative velocity. And this velocity is increasing. Negative only means that its direction has changed. And now the velocity is decreasing. So the velocity is decreasing in the P portion and the velocity is decreasing in the R portion. So which sections of the graph show where the magnitude of the velocity of the train is decreasing? So in the P, the train's velocity is decreasing. In the R portion, the velocity of the train is decreasing. So we think B is the choice. P and R, let's check. Question number 4, B is the right answer, sir. Then we have question number 5. He says a metal disc is squeezed in the jaws of a vice. So vice is that device which hold the things. Okay. So the which property of the metal disc is unchanged when it is squeezed? Mass, obviously mass will not change whether you change its shape by the pressure, by squeezing. Radius will change. Distance between its atoms, that might change because you decrease the volume. Forces between its atoms, forces might change if you reduce its size. But the one thing we definitely do not change by squeezing is the mass. So question number 5A is the choice, which is the right choice, sir. Then we have question number 6. The gravitational field strength in space is smaller than on the Earth surface. How are the mass and the weight of a satellite affected as the satellite moves away from the surface of the Earth and into the space? You see, the mass do not depends upon your location. No matter where you are, the mass remains the same, but the weight depends upon the distance from the Earth. So if you are away from the Earth, the mass and the weight will decrease. If you are near the Earth, your weight will be more. So, so how are the mass and the weight of the satellite affected? Both the mass and weight are unaffected. No, the mass decreases and the weight decreases. No, the mass actually remains unchanged. The mass increases and the weight is unaffected. No, the mass is unaffected and the weight decreases. So I think D is the right option, sir. The weight will decrease and the mass will not change. Question number 6, D is the right answer, sir. Your answer is right. Now we are going to the next question. The next question coming up on your screen is question number 7. A material has a density of 2.4 grams per centimeter cube. What is the density in kg per meter cube? So if you want to convert the grams into kg, you will have to divide it with the 1000. And if you want to convert the centimeter cube into the meter cube, you will have to divide it with the 100, 100, 100. So let me show you. I have done this on a paper. So let me show you. So because the gram is upstairs in the numerator, so we will write 1000 downstairs. And because the centimeter cube is in the denominator, to convert it into the meter cube, we will write 100, 100, 100 in the numerator. So 2.4 multiply 100 multiply 100 multiply 100 divided by 1000. So you will get 2400 kg per meter cube. 2400 kg per meter cube. So the answer looks D, question number 7. I think D is the right choice. Question number 7, D is the right choice. Okay, so let's go to the next question. The next question is question number 8. An object falls vertically through the air. Which diagram represents the forces acting on the object? So when you are falling down, the weight will be acting downward. And because you are falling downward, so there will be air resistance which will be opposing your motion. And the direction of the air resistance will be in the upward direction. So the force of the air will be in the upward direction, and the force from the earth on the object, that will be in the downward direction. So what is the best diagram which is representing this fact? I think A, force of the air on the object, that will be opposite to the motion. and that will be in the upward direction, and the force from the earth on the object will be in the downward direction. So I think question number 8, I think A is the choice. Question number 8, A is the right choice. So let's go to the next question. And next question coming up on your screen is question number 9. He says a force F is applied on a lever at distance L from the pivot as shown. So they are basically showing you a door, and in this door, here you have applied the force, and this is the line of action of the force. This is your lever, and this is the pivot. Okay, so this can be a door, this can be a screwdriver, a spanner. I mean, so this is that lever. Here you have applied the force. The force is not making 90-degree angle with the lever. Okay, so here we have the pivot about which this lever will be rotating. So their question is the length D is the perpendicular distance between the force and the pivot. Which expression is the moment of the force F about the moment of the force is the product of the force and the perpendicular distance between the line of action of the force and the pivot. So it must be D. This is that perpendicular distance between the pivot and the line of action of the force. So the moment of the force will be F multiplied D. So I think C is the choice, sir. Question number 9, C is the right choice, and it is the answer, sir. Okay, so we are going to the next question. The next question coming up on your screen is question number 10. A rocket is launched vertically upwards by a constant force from its engines. The data for the launch is shown. The weight of the rocket is 1.9 million Newton. Average air resistance is 0.10 million Newton. And the force from the engine is 3.5 million Newton. How much of the work done on the rocket is used to increase its speed in the first 100 meters? So the weight of the rocket you have to overcome. You have to overcome the average air resistance, and the rest of the force, which is coming from the engine, will be used for the acceleration. So from the 3.5 million Newton, we will subtract the weight of the rocket, which is 1.9 million Newton, and we will also subtract the average air resistance, that is 0.1 million Newton, and the rest of the force will be used to move the rocket. And because you are going to move 100 meter, so that rest of the force, we will multiply it with 100 meter, and that will give you the distance, the work done in moving the rocket, or to increase the speed of the rocket. So how much of the work done on the rocket to use? Okay. So let me show you question number 10. We have done this. Okay. So the resultant force will be the force from the engine minus the air resistance minus the weight of the rocket. So 3.5 minus 0.1 minus 1.9. So 1.9 million Newton. So the work done by this force, which will be used to increase the speed of the rocket, that will be 1.5 into force into distance. And the rocket has moved 100 meters in the direction of this force. So it will be 1.5 multiplied by 100, and it will be 150 million joules, yeah, or you can say megajoules. So 150 megajoules or million joules, 150. Do we have this answer? Yes, A. So we think question number 10A is the choice, sir. Question number 10A is the right choice, sir. So we have question number 11 coming up on your screen. Which equation is used to calculate the efficiency of an energy transfer? You know, the formula for the efficiency is useful output energy divided by the total input energy, or you can say useful output power divided by the total input power. So useful energy output divided by total energy input. A is a perfect answer, sir. and the rest of the answers are not right. Question number 11, we think A is a perfect answer. Question number 11, A is the right answer, sir. Okay, so we have question number 12 coming up on your screen. They say, four objects of different masses are lifted through different distances in different amounts of time. In which combination of mass, distance, and time is the greatest power transferred? Okay, so we have to calculate the power in each case. The power is equal to the work done divided by the time, because they are going vertically upward. So it will be uh, the 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 gain in the potential energy divided by time, mgh divided by time. So for each case, there are four cases given here. For each case, we will find out the power, which will be the gain in the gravitational potential energy divided by the time. So for each case, we will do this calculation. For A part, it will be 2 into 9.8 into 2 divided by 3, and that is 13.0 joules. For B part, it will be 1.5 multiplied 9.8 multiplied 2.5 divided by 2, and that is 8.375. C part is 2 multiplied 9.8 multiplied 2 divided by 1.5, and that will be 26.13. And for the D part, it will be 1.5 multiplied 9.8 multiplied 2.5 divided by 1.5, and that is 18.375. So the greatest power is 26.13, and the least power is 13. So I think C, let's check what they ask us. Greatest power, C is the answer, sir, because C has shown 26.13 watt. So we think C is the answer, sir. Question number 12, C is the answer. Yes, our answer is right, sir. Question number 13, air at a pressure of 1 expo 5 Newton per meter square is trapped in a container by a piston. A force is applied to move the piston down into the container. The temperature of the air remains constant. The distance between the base of the container and the piston decreases from 0.18 meter to 0.15 meter. What is the new air pressure inside the container? So, when the temperature remains constant, and we are talking about the gas pressure, then we have P1 V1 equals to P2 V2. And here, suppose if with the air pressure, the pressure when it was normal air pressure, this one, that is P1. And we can take the volume as cross-sectional area multiply the length. Okay, because we know the length of the air column. In both the cases, in the first condition and in the second condition, in the first situation and in the second situation, the cross-sectional area of the air is same. So, in the place of the volume, I can write cross-sectional area multiply the length of the air column, and then I can solve it very easily. So here we have P1 V1 equals to P2 V2. P1 and the place of the V1, I will write the cross-sectional area multiply length 1 and equals to P2 V2. In the place of the V2, I will write cross-sectional area multiply the length 2. Because in both the situations, the cross-sectional area is same. So from both the sides, I will cancel A. Now, the pressure one is 1 expo 5 Pascal, and the L1 is 0.18 centimeter or meter, I think. The unit was in meters, sorry. It was in meters. And P2 is the question, and the length 2 is 0.15. So the P2, if I make it the subject, so it will be 1 expo 5 multiply 0.18 divided by 0.15. And the P2 will be 1.2 expo 5 Newton per meter square. 1.2 expo 5 Newton per meter square. So let's check what is the answer. 1.2 What is my answer? 1.2 expo 5 Newton per meter square. 1.2. So I think C is the choice, sir. Question number 13. C is the choice. This is how we have solved it. C is the choice. Question number 13. C is the right choice, sir. Hopefully you understand. Okay, so here we have a sealed gas syringe contains a gas that is kept at constant volume. Okay. Which row describe how a change in the temperature of the gas affects its pressure? You see, if we're talking about the gas pressure, and if the temperature is increased and or decreased, I mean, the volume is constant here. And when the volume is constant, then the pressure is directly proportional to the temperature. If the volume of the gas is constant, and when you increase the temperature, the pressure of the gas inside that syringe, it should increase. And when you decrease the temperature, the pressure of the gas must decrease. So let's see how many options we have. Temperature decreases, pressure of the gas increases. That's wrong. The temperature decreases, gas pressure unchanged. That is also wrong. The temperature increases, the pressure of the gas increases. That is right, because the temperature and the pressure, they are directly proportional to each other. So I think C is the choice, sir. And I think C is the choice. Let me make sure that you can see the whole question. So we think C is the choice. Question number 14, C is the right choice, sir. Okay, then we have question number 15 coming up on your screen. He says, the melting temperature of the gold is 1064 degrees centigrade. What is the melting temperature of the gold in the Kelvin scale? You know, K is equals to C plus 273. And this is the formula which we use. So here we go. So K is equals to 273 plus degree centigrade. So 273 plus 1064, and that is 1336 Kelvin, 1336 Kelvin, 1337, 1330. I said 6. It's 1337 Kelvin. So we think D is the choice. Question number 15. D is the choice, sir. Question number 15. D is the choice, sir. Question number 15. D is the choice. This is, see. Let me show you. Yeah, this is how it is done. Here we go. Question number 16. That table shows the melting and the boiling temperature of 3 elements. Okay. So we have argon. The melting point is minus 189 degrees centigrade. Boiling temperature is minus 185. Nitrogen, minus 210. Melting point is, and its boiling point is minus 196. Oxygen, its melting point is minus 218, and its boiling temperature is minus 183. At which temperature are the 3 elements in different states? So for this, I have to make a number line, and let me show you. I have drawn a number line. Okay, so here you can see I've written here minus 170, minus 180, minus 190, minus 200, minus 210, and minus 220. So because so we have their melting, for example, let me show you. For example, argon minus 189 and 185. So from 189 will be here somewhere, and 185. Okay, 185 will be here somewhere. Okay, so from 189 to 185, the argon will be in the liquid state, and the temperature higher than 185, it will be in the gas form, and below this, the argon will be solid. In the same way, you can see here, nitrogen, minus 210 and minus 196. At minus 210 till minus 196. Minus 196 will be here somewhere. So in this portion, the nitrogen will be a liquid. Below this temperature, the nitrogen will be a solid. And above this temperature, the nitrogen will be in the gas form. Then we have oxygen from minus 218 to 183. Minus 218 is here somewhere until here, which is 183, minus 183. Oxygen is in the liquid state, and above this temperature, the oxygen is in the gas state, and below this temperature, the oxygen in the solid state. So we are looking for that portion of the temperature in which all of them are in different states. They are in the different states. Okay. So yeah, this portion you can see here. In this portion, the nitrogen, argon will be liquid. The nitrogen will be gas, but this will be in the liquid state. Gas. This portion. Here you can see it's solid. Oxygen is liquid. And this is gas. This small portion. It is solid. This is gas. This is liquid. So we are looking basically for that temperature in which the three of them are in different states. So this small portion here, argon here is solid, nitrogen is in gas, oxygen is in liquid. So what are their options? At which temperature the three elements at different states? Okay, so what is this temperature? This temperature is from minus 190, 95, 94, something. Okay. Minus 190, I think. C is the choice. Yes. Here, at this temperature. Three of them are in different states. A little tricky question. It's easy, but it's tricky. Question number 6. I think C is the choice, sir. Question number 16. C is the right choice, sir. You see, I draw a number line which is showing the temperature because the temperatures are negative. Then I showed the melting point and the boiling point of the argon on it. I showed the melting point and the boiling point of the nitrogen on it. I showed the melting point and the boiling point of the oxygen. And then for each, I made that from this temperature, it is in the liquid state, it's in the solid state, it's in the gas state. And then I looked a portion where all of them have different states. And this is the best. Okay. So it's a little tricky question, not an easy one. Question number 17 coming up on your screen. The diagram shows a liquid at room temperature in a beaker. What reduces the rate of loss of liquid by evaporation? So if we want to reduce the rate of evaporation, so blowing air across the top of the beaker, that will increase the rate of evaporation. Heating the liquid, that will also increase the rate of evaporation. putting a lid on the beaker that will reduce the rate of evaporation, transferring the liquid to a beaker with a larger diameter. Yes, that is true. No, this will not reduce the uh, blowing air across the top of the beaker. It will increase the rate of evaporation. Heating it will increase the rate of evaporation. Putting a lid on the beaker that will reduce the rate of evaporation. Transferring the liquid to a beaker with a larger diameter, it will increase the rate of evaporation. We are looking where you will reduce the rate of evaporation. So the rate of the evaporation will be reduced when you will put a lid on that beaker. So I think C is the choice, sir. Question number 17. C is the right choice. We were looking situation in which the rate of evaporation will decrease. Then we have what is the color and what is the texture of the best absorber of the infrared radiation. To be the best absorber of the infrared radiation, the texture must be dull and the color must be black and dull. So we think question number 18, B is the choice. Question number 18, B is the right choice. Question number 18, B is the choice. Okay, then we have question number 19. He says, which row gives the velocity and wavelength of a wave that is an ultrasound? Okay, so the velocity is given, the wavelength is given. We can find the frequency of each of them. Ultrasound is that wave whose frequency is more than 20,000 hertz. So in each case, we will find out the frequency. And you know the frequency V equals to F lambda. V equals to F lambda. So F is equals to V divided by lambda. But the lambda must be taken in meters. We will take the lambda in meters. Question number 19 coming up on your screen. So in each case, I'm going to find out the frequency. So V divided by lambda, 330 divided by 6.6 divided by 100, and that is 5,000 hertz. So this is not ultrasound. B part is F is equal to V divided by lambda. So 890 divided by 89 divided by 100, and that is 1,000 hertz. This is also not ultrasound. So then we have C part, V divided by lambda, 1500 divided by 6 divided by 1000, and that is 25,000 hertz. This can be ultrasound. Ultrasounds are those sound waves whose frequency is more than 20,000 hertz. So in the D part, the frequency is 16,000 hertz. So C is ultrasound. We think C is ultrasound. Let's check. C, question number 19. C, we think question number 19, C is the right choice, sir. Question number 19, C is the right choice because when we calculated the frequency of the sound in the C option was 25,000, which is the frequency for the ultrasound. Okay, so we have question number 20 coming up on your screen. The diagram shows a ray of light incident on a plane mirror. What is the angle of reflection? You see the angle which they have shown. This is not the angle of incidence. So what we will do, we will draw a normal here. Okay. So we will draw a normal here. And the incident ray will make an angle. So this is your normal. Normal is making 90-degree angle with the surface of the mirror. And so this angle 90 minus 30, this angle will be 60. So the angle of the incidence is 60. So the angle of reflection will be also how much? It will be equals to 60 degree. So we think the angle of the reflection is 60 degrees. So the B is the choice. We think B is the choice. And question number 20, B is the right choice. Sir. Question number 20, B is the right choice. Question number 21 is showing up on your screen. An object O is placed in front of a plane mirror. Which diagram shows the image F formed by the plane mirror? Okay, so you know the distance of the object and the distance of the image from the lens must be uh, same, and the image is virtual, and so the C and D cannot be the answers because the image is formed on the surface of the plane mirror, which is not possible. The image is formed virtually behind the mirror. Okay. So I think let's check. I think A A looks the best answer, sir. Yes. Image of this point must be here. Image of this tail must be here. So I think A is the best option, sir. Question number, what question this is? Question number 21, I think A is the choice, sir. Question number 22, the diagram shows a ray of light traveling from air to medium Q. What is the critical angle for the boundary between the medium Q and air? So I will check how much is the angle of incidence here. So I need to know what is the angle of incidence. The angle of incidence here. And then I will have to know how much is the angle of reflection here. And then N will be equals to sine I divided by sine R. So once I know the refractive index, then I will write the formula N is equals to 1 divided by sine C. And from there, I will be able to calculate the critical angle. So question number 22. Okay, so where we have question number 22, angle of incidence is 60, sorry, here. So the refractive index is sine I by sine R. So the I is 48 degree and the R is 40.5 degree. So N will be, refractive index will be sine 48 divided by the sine of 40.5, and that will be 1.14. So the refractive index is 1.14. Now, you know the N is equals to 1 by sine C and 1.144 is equals to 1 by sine C. So sine C is equals to 1 divided by 1.144. So the C will be equals to 1 divided by 1.144 is 0.874. So C will be equals to sine inverse of the 0.874. So when you take its sine inverse, the C angle, the critical angle will be 60.9. So 60.9 is the answer, sir. So let's check. 60.9. 60.9, I think C is the choice, sir. 60.9 C is the choice. And our answer is right. And this is how this is done. Okay. So C is the choice. Question number 22, C is the choice. Then we have question number 23 coming up on your screen. Which two waves are components of the electromagnetic spectrum? Light and sound. You know, the light is a component of the electromagnetic spectrum, but the sound is not. Ultrasound and ultraviolet. Ultraviolet is the electromagnetic part of electromagnetic spectrum, but the ultrasound is not electromagnetic spectrum, part of electromagnetic spectrum. Water waves and infrared. Infrared is part of electromagnetic spectrum, but the water waves are not. X-rays and the microwaves, yes, the X-rays and the microwaves both belongs from the electromagnetic spectrum. You know, the electromagnetic waves are microwaves, radio waves, microwaves, infrared. visible, ultraviolet, X-rays, and gamma rays. So we think D is the choice, sir. Question number 23. Question number 23, D is the choice, sir. Question number 23, D is the choice. Question number 24 showing up on your screen. The diagram shows an iron nail in 4 different situations. In which diagram is the nail an induced magnet? Here you have placed the magnet near you have placed the nail which near a magnet, obviously. So due to the magnetic induction, this nail will also start behaving like a magnet. Here you have placed the nail near an iron bar, so the nail will not become an electromagnet. So, sorry, that not a magnet. Okay, it will not behave like a magnet. Okay, in this situation, because you have not closed this switch, the switch is open, so the DC current is not passing through this coil, so this nail will not behave like a magnet. In this situation, the switch is open, so this coil is not an electromagnet because the switch is open. So this iron nail will not behave like a magnet. So in which diagram is the nail induced magnet? The induced magnet will be in the shape A. When you have placed a nail near a magnet, this nail will also start behaving like a magnet. So A, question number 24, A is the choice, sir. That is right choice, sir. Question number 25, he says, which row correctly shows a magnetic material and a non-magnetic material? The magnetic materials are iron, steel. Non-magnetic materials are aluminium, copper. So the magnetic material can be iron and the non-magnetic material is copper. So I think C is the best option, sir. Question number 25, C is the right choice, sir. Question number 26, a freely suspended magnet is held perpendicular to a uniform magnetic field as shown. The magnet is viewed from above. What happens to the magnet when it is released? Okay. So, because the north always align itself with the direction of the magnetic lines in that area. So this north will come here and the south will go there. So when this bar magnet will be aligned, it will be parallel to these magnetic lines, and the north of the bar magnet will be in the direction where you have the heads of those magnetic lines, and the south will be on the tail sides of those magnetic lines. When this bar magnet will become parallel to the magnetic lines, it will stop there. So it turns 90-degree clockwise. So it's supposed to turn 90-degree. Anti-clockwise. It's supposed to turn 90-degree anti-clockwise and then stops moving. So the best option is that it will move. So this north will go down, the south will go like up, and so this will be anti-clockwise movement. And when the north and the south are aligned with those magnetic lines, it will stop moving. So it turns to 90-degree anti-clockwise and then stops moving. So I think B is the best option, sir. Question number 26, B is the right option. Okay, so we have question number 27 coming up on your screen. He says, plastic rod becomes charged when it is rubbed with a cloth. So you have rubbed the plastic rod with the cloth. Which statement gives the reason for the charge on the rod? So you see, when you rub a plastic rod with the cloth, and the reason for the charging is that the transfer of electrons have taken place. The plastic rod loses protons. No, like the transfer of electrons takes place. No protons. Okay, the plastic rod loses electrons and become negatively charged. The party who loses electrons, that should become positive, not negative. The plastic rod gains protons and becomes polycharged. The protons are not given, not received. The plastic rod loses electrons and becomes positively charged. That is true. The party who loses electrons becomes positive. So D, question number 27. D is the answer, sir. That answer is right. So we have question number 28. He says four resistors. Each of the resistors are connected in series with the cell of EMF E. From left to right, what is the current in each of the resistors? Because all of them are connected in series with each other. So all of them will have the same amount of the current. So whatever the current will come out of the battery, the same amount of the current will flow through each resistor, because there is only one path for the current here. And so in each resistor, the current will be same. Now, how you find the current coming from the battery? And that is the total resistance divided by the EMF. So, sorry, the EMF divided by the total resistance. So the EMF is E and the total resistance is 4R. So in each of the resistors, the current will be same. So E divided by 4R, E divided by 4R, E divided by 4R, E divided by 4R. And I can tell you that A is the right option. A is the right option, sir. Question number 28, A is the right option. Question number 28, A is the right option. Okay, then we have question number 29. He says, how can 1 volt be expressed? You know, the voltage is equals to, how can 1 volt be expressed? Something happened with my paper. It has become losses. Okay. You know, the volt is equals to the energy divided by charge. Energy divided by charge. So it should be joules per coulomb. Energy, the unit of the energy is joule, and the unit of the charge is coulomb. So D is the choice, sir. Question number 29, I think D is the choice. Yes, sir, that's right. Question number 30. X is a piece of wire with the length L, area A, and resistance R. Wire Y is made from the same material and is connected to the wire X to produce a component with a total resistance of R by 2. So now you know you have connected two wires and the resistance of the combination is less than the resistance of one of the individual wires. So that happens only when you connected them in parallel. And because the resistance has become half, that means uh, the so that happens only if they have the same resistance. So same resistance is only possible if you make the length 2 times. The cross-sectional area uh, should become 1 by 4. Sorry, 1 by 2. If you make the length 2 times, the cross-sectional area must become 1 by 2, which means 0.5. So for example, if you have increased, if you have made the length 4L, means the length L is the first wire. If the second wire has the 4L, the length is 4L, then its cross-sectional area should also be 4A to get the same resistance. You see, the total resistance is R by 2 in the parallel combination, and that is only possible if both the resistors have the same resistance. Now, because the second resistance, its length has increased. So, for example, as compared to the first one, it is 4L, then its area must be 4A to make the same resistance. So I think, and they should be connected in parallel, and I think C is the right choice. Tricky question. Question number 30. C is the right choice. A very tricky and the conceptual thing. Here we says which circuit contains a fuse and a diode. In the fuse, this is the symbol for the fuse. This is the symbol for the fuse. This is the symbol for the fuse. And this is the symbol for the diode. Diode. Which circuit contains a fuse and a diode? So only this section, this circuit has fuse and a diode. D choice. Question number 31. Question number 31, D is the right choice, sir. Then we have question number 32. He says, how is the energy transferred within a kettle that is powered by the main supply? By electric work done to chemical energy. No, the electrical work done to thermal energy, that is true. By mechanical work done to chemical energy, no. By mechanical work done to thermal energy, no. In the electric kettle, the electric energy converts into thermal energy. So B looks the best option to me, sir. Question number 32. B is the right choice, sir. Question number 32. B is the right option, sir. Then we have the question coming up on your screen. That is question number 33. He says a magnet moves through a coil of wire as shown. So the direction of the motion of the magnet is like this north pole is facing the left side end of the coil. So this north pole is approaching the P side of that coil. Magnetic poles are produced at the two ends of the coil as the magnet enters and as the magnet leaves the coil. So which pole is induced at the P when the magnet enters the coil, and which pole is induced at the Q when the magnet leaves the coil? So see, so when the magnet enters, so basically what is happening? The north is approaching this left corner to stop it. What will happen? A north pole will be created here. Okay, to stop this approaching north. That is the rule of the induction, electromagnetic induction. So to stop this approaching north, a north will be produced here. That will what happens when this is approaching. So when it enters here and then it leaves, so the south will be facing this side, and because the south will be going away, to stop the going away south, this will become a north. Then this will become a north. Let me change the color. Then this will become the north. And when this will be, why this will become the north? Because here you will have a magnet, and when it will be going away, it is going like this way, and its north will be here, and its south will be here. So because this south, which is facing this right side of this coil's end, it is going away. To stop the going away south, it should have become north. So north, 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 north. So the pole at the P, let me increase the size so you can see the whole thing. Okay, so the pole at the P, when the magnet enters the coil, it will be north. And the pole at the Q, when the magnet leaves the coil, that will be also north. So we think A is the choice, sir. Question number 33, A is the choice. Question number 33, A is the choice. Yes, question number 33, A is the choice, sir. So here we have question number 34 coming up on your screen. So it says a straight vertical wire carries a current in the direction shown. Okay. So what is the pattern of the magnetic field around the wire seen by an observer viewing the wire from the position? So the current is going from this positive from this is the positive terminal of the battery. So the current is going from here, it's going downward and then entering into that. So the current is basically going downwards. You will take your right hand, hold this in your right hand such a way your thumb is along the direction of the conventional current, which flows from the positive to the negative, and then you look at from the top. So when I look at my fingers, they are telling me clockwise. So they should be clockwise, 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 clockwise. D is the right answer, sir. I think question number, they are showing clockwise. Clockwise. D, I think, is the best option, sir. Question number 34. D is the right choice. We use the right hand grip rule for the straight conductor, in which the thumb of the right hand is along the direction of the conventional current, and the curves of your finger shows the direction of the magnetic field. And we are looking from the top. And the magnetic field around that wire will be clockwise. So D is the choice, sir. I hope you understand. Question number 34. So then we have question number 35. Which part of a simple DC motor reverse the direction of the current in the coil once every half rotation of the coil? That thing is called the split ring commutator. The split ring commutator makes sure to reverse the direction of the current in every half cycles of the coil's rotation, and that changes the direction of the force acting on the sides of the coil. And that makes sure that the coil continues to rotate in the same direction. Okay, so we think D is the choice, sir. The split ring commutator. D, question number 35. D is the right choice, sir. Then we have question number 36. Which statement about the nuclide notation X, Z, R is correct? Z is the nucleon number which is different for different isotopes of X. That is true. The nucleon isotopes will have the same proton number, but their nucleon number will be different. So A looks good, answer to me. BR is the proton number, which is wrong. Z, C choice. Z is the nucleon number, that is wrong. Z is the proton number, true, which is different for different isotopes of X, that is wrong. The proton numbers of the different isotopes is same, but their nucleon number is different. A, I think, is the right choice, sir. Question number 36. A is the right choice. The definition of the isotopes. They have the same proton number, but their nucleon number is different. It says, question number 37. During a radioactivity experiment, the background reading is 28 counts per minute. A radioactive source is placed 2 centimeters in front of a detector, which is connected to a counter. Okay. So counter readings are taken with and without sheets of different metals placed between the source and the detector. So when there is no sheet, the reading is okay. So when there is no sheet, the reading on the counter is 750. When there is a thin card, the reading is 750. It means because if there are alpha particles, they would have been stopped by the thin card, but the reading has not changed, so it is not emitting alpha particles. Then you have 5 millimeter thick aluminium. The reading has dropped to 478. So because there was no alpha particles, but now when you place the aluminum sheet, the reading has changed a little bit. It means it has beta particles, but there is a high reading shown. That means it also has gamma rays, because the gamma rays can pass through the aluminum, but the beta particles cannot. So that means there are no alpha particles, because when we place the paper, the reading does not change. So it means it does not have alpha particles. Alpha particles are not given out, but when we place the aluminium, the reading changed, but the reading has not come down to the background. So that means it has beta particles and it also has gamma rays. So which type of radiations are being emitted by the source? So it is emitting beta particles and gamma rays only. It's not emitting alpha particles. D is the choice, sir. Why alpha particles are not there? How do I know? Because you know that when you place the paper, the reading did not change. The alpha particles can not pass through the paper. Question number 37, I think D is the choice, sir. That is right choice, sir. Question number 38 coming up on your screen. A radioactive isotope is injected into a patient as part of a medical test. The radiation emitted is detected outside the body. What is suitable properties for the isotope? You know, this isotope, it should emit either the beta particles or gamma rays because this radiation should be able to penetrate through the flesh and skin. And second thing is its half-life should be few hours, not few years, not few minutes. Okay, its half-life should be few hours, so that you have to keep that patient in under observation due to the radiation only few hours. So alpha particles, no. The alpha particles cannot pass through the skin. So beta particles, yes, a few years, no, not few years. Gamma rays, yes, can be and a few hours. That is right. Gamma rays, a few years, not few years. Gamma rays and a few years. That is the best option, sir, for using in the hospital. C, question number 38. C is the choice. I hope you understand why we are not taking others, because we do not want the patient to remain radioactive for a very long time, and so we have to keep the patient only at hospital like 4 hours, 6 hours, maybe 10 hours. So its half-life should be in hours. And we cannot use alpha particles because the alpha particles will not be able to pass through the skin. So I think gamma rays and a few hours. C is the choice. Question number 38. C is the right choice, sir. Question number 39. A student writes four statements about the solar system. Light takes approximately 3 expo 8 seconds to travel from the sun to Earth. That is wrong. One is wrong. What 3 in expo 8 is the speed of the light, and that is meter per second. The Earth takes approximately 24 hours to rotate on its axis once. That is true. The Earth takes 24 hours to rotate on its axis. The moon, the second option is right. And the moon takes approximately 1 month to orbit the Earth. That is also right. The sun takes approximately 365 days to orbit the Earth. That is wrong. The sun do not orbit around the Earth. Earth orbit around the sun. So the second and third one is correct. Which statements are correct? Second and third one. Okay, C looks the best option to me, sir. Question number 39. C is the right option, sir. Question number 39. C is the right option. Question number 40. What is never formed by the explosion of a red supergiant? A black hole. Red supergiant happens in the case of very large stars. A black hole, that can happen. A neutron star, yeah, that can happen. A white dwarf, no. A white dwarf is formed in the case of small stars. Neutron star or black hole, that can be formed at the end of the life of a larger star. So a black hole, yes. A neutron star, yes. A white dwarf, no. New heavier elements. What is never formed? So by the explosion of, so a white dwarf is never formed because that happens only in the case of small stars. So never, what will never happen? A white dwarf. What will never happen? Question number 40, C is the choice. A white dwarf is formed when Uh, when a small star ends its life. Let me increase the size. So, my dear students, in this video, we have reached the end of this paper. In this video, I have presented you the solution of this paper. Please remember, this paper and the marking scheme which we were using, they have been created by the Cambridge and not by me. I have only prepared its solution and written its solution, and I am making video about the solution. This paper, this marking scheme is coming from the Cambridge. So thank you very much for watching this video. If you think that this video is helpful, please share the link of this video on your WhatsApp, on your Facebook, on your TikTok, on your Instagram, on your Snapchat, wherever it is possible, on your LinkedIn. So, when you do this, you actually support my work. Please also like this video, subscribe my channel. Your support is very important for me. I hope this video will be very helpful to you. So thank you very much. Have a good day. God bless you all.